Hi, good day. Today, we will discuss one of the most important topics in research, the research design. Okay, and these are the learning objectives for today's session that at the end, you will be able to distinguish various classification of research design and then differentiate them, each one from each other. Okay, so let's begin with a definition of what research design is. We can also talk of an epidemiologic study design because we will really give emphasis on the epidemiologic study design when we talk of research design here. Okay, so it's a plan or course of an action that the researcher takes to solve the research problem. So we have the problem, we now want to make a plan to solve that research problem. And I would like to emphasize this, that the research design is not the method of data collection. And the reason why I'm emphasizing this is that people talk of a retrospective study design or a prospective study design. May I tell you that there is no such thing as a prospective or a retrospective study design, because when we talk of prospective and retrospective, we actually mean the method of data collection. So prospective, the method of data collection is getting information, collecting data forward. And when we talk of a retrospective method, retrospective means collecting information backwards using the medical records. But that will be discussed later on when we talk of data collection. It is a strategy or approach by which the research question can be answered. And it is how to go about solving the problem, describing what will be done to answer the research question. Okay, so this will be the components and the sequence of implementation in choosing a particular study design or research design. We choose the study population. We select and classify or assign subjects. Later on, we'll be talking of this assignment. We assess and observe the variables, and then lastly, we process and analyze the data. Okay, now basically, there are two types of research design, the descriptive and the analytic. Descriptive and the analytic. When we talk of a descriptive study design, we are talking of an inquiry into an unknown phenomenon or the occurrence of an event. We will just look into the characteristics of that phenomenon or event and then categorize that phenomenon into some descriptive variables. And that is why we call them descriptive study. We just describe that phenomenon. And in a descriptive study, we do not intend to explain or to seek or determine relationship, but a descriptive study seeks knowledge for better understanding of the nature of the subject of the study. Again, a descriptive study does not intend to explain or determine the relationship. And then it goes without saying that when a study looks into the relationship between two variables, we are now talking of an analytic study, but that's going ahead. Okay, now a descriptive study identifies possible determinants, problems, risk factors, which could be used later on as basis for hypothesis formulation, and then subject that study to further analytic studies. class, let me just emphasize this to you. Okay, when we talk of a descriptive study, a descriptive study only identifies possible determinants, because if a study looks into the determinants, problems, risk factors of a disease, that study is an analytic study. Again, descriptive study only identifies possible. The key word here is possible determinants. So that these studies later on, because this could be the possible risk factors, we subject now this hypothesis from a descriptive study, we can generate hypothesis and then subject that study to an analytic study. So we talk of the different types of descriptive studies. We actually have many. The case report or the case series, later on we'll be discussing this. A cross-sectional study is also a descriptive study, and an ecologic study, or what we call the correlation study. We'll discuss each of these one by one. Okay, we first talk of a case study and a case series. These are two different studies. A case study is different from a case series, but they are very much related to each other. That is why we discuss this as one. And so this is the most basic type of a descriptive study. We talk of individuals, studies of individuals. In descriptive studies or case study or a case series describe the characteristics and clinical features of a single patient. If it's a single patient, we call it a case report or a case study. A case report and a case study, they are synonymous. Or if we are talking of the characteristics and clinical features of a group of patients with similar manifestation, so not just an individual patient, then that becomes now a case series. So again, if we are talking of a single patient, that is a case study or a case report. But if we are talking of describing characteristics and clinical features of a group of patients, so many patients, not just one group of patients, and they have similar manifestation, then we are talking now of a case series. Okay, so in a case report or in a case series, we have to have a comprehensive documentation of a particular patient or case. Let me just emphasize this to you offhand, that when we talk of case in research, we mean disease. So when we talk of case report or a case series, we're actually talking of a disease. Okay, so it is a detailed case reports, and case series are a detailed report starting from the beginning of the disease, following the progress up to the outcome of the disease or case, if it is a case study, or cases, if it is a case series. And patients in a case series may occur in a relatively short period of time, meaning that particular disease, and there are many diseases, there are many patients with this same disease in a short period of time. The disease occurs in a relatively short period of time. Now, a case may be documented this way because it is of a very rare condition, meaning we make a case study or a case series because these are of rare condition. We don't make a case report for a disease that's common, because why make a case report for a case that's common, for a disease that's common? But we normally make a case study or a case report for a disease that is rare. That is rare because we want to inform the medical community that such a case, such a disease does happen, or it can happen. Now, it may also be a common disorder. We can have a case study or a case report that is common, but it is presenting to us differently, epidemiologically, or unusually. So the presentation is different from the other diseases. So we can also make that case as a case report or a case study. If it presents to us, it may be a common disorder, but presenting to us unusually, epidemiologically. And it has progressed, or it has progressed to a very unusual manner. So it begins with a usual presentation, but it progresses to a very unusual manner. Then we can make a case report out of that. Or it can be part of surveillance and investigational activities. For example, dengue fever is a common disease. It's a common disease, okay? So, but we can make a case series of this if this is part of the surveillance or investigational activities. Now, purpose of a case series to come up with a common or modal information, because we have many patients. So what are the common or modal information such that in the end, a conclusion of what is most common to all patients with the disorder or the disease being studied can be made. Okay. So merits of case reports. It is inexpensive and easy because you only have one patient, and good for very rare occurrences because we want, as I said, to inform the medical community that such a disease can happen, and it lays the groundwork for future and more powerful studies. If a case study now becomes a case series, and then we can now make an analytic study from that case series that we have made. For example, when AIDS was first discovered, it was reported as a case report. A medical doctor saw a case with unusual presentation, with TB, with malnourished, cachectic, with monoliasis all over, with diarrhea, with pneumonia. Okay, so that's something that's rare, and so he reports it in a medical journal, and then another physician reads that case and then said to himself, I too had the same case, and published it in a medical journal, and many others followed suit. And then an epidemiologist now combined all these cases as a case series. And in that particular case series, the common modal information that epidemiologists saw is that a lot of them are homosexual. And so a hypothesis was made with regard to that disease, now called AIDS. They still didn't know what the disease, what the disease was. And so there was a hypothesis that was made saying that that disease, now called AIDS, is associated with homosexuality. And so an analytic study was then made. So from that case series, they generated a hypothesis, and then an analytic study was then made. So from the case series, we can generate hypotheses, and then we make an analytic study. But of course, now we know why there is a relationship between that particular disease, AIDS, and homosexuality. Limitation. This is not a true epidemiologic study. That is why we need a better analytic study, because as we said, case series will just generate hypotheses. Now let's go to the next. This is number 3, because the case study and the case series are really two types of studies. They are different. One, the case study only looks at a single patient. The case series looks into a series of patients. Okay, now in a descriptive cross-sectional study, we examine the disease and other characteristics or variables of interest as they exist in a defined population at one particular point in time. And I would like to emphasize this. We examine the characteristics of or the variables that you are interested in of that disease, at one particular point in time. And it is also called a prevalence study or a survey. It measures, therefore, the prevalence of the disease. And I will be giving more explanation of this prevalence of the disease when we talk later on of analytic studies. Now, in a cross-sectional study, the investigator may have a problem in mind at the start, and from the population of it, from a population, individuals with the disease in question are identified, and then the investigator then characterizes those people with the disease. So makes a description of the different characteristics of the people with that disease. That's a cross-sectional study looking into their characteristics at one particular point in time. Uses of cross-sectional studies for community diagnosis. So these are the most common diseases in that particular locality. So for community diagnosis, for assessment of health needs, planning, utilization, and evaluation of healthcare services. So what are the most common diseases that occur in that community? And so we need to assess their needs, plan, and utilize, evaluate healthcare services, and for raising the question of the presence of association for generation of etiologic hypothesis. Again, a cross-sectional study, which is a descriptive study, can be done to generate hypothesis, And when you generate hypothesis, you now make an analytic study. And for determining the status of a disease or condition. Now, let's go to the fourth epidemiologic study, the ecologic study, or the correlation study. In an epidemiologic study, we use data from the entire population to compare disease frequencies between different groups during the same period of time or the same population at different points in time. The data, the unit of measurement in an ecologic study is the entire population, So again, as I said, the unit of analysis is a group defined geographically on the basis of demographic variables and then the time, because as we said, we can compare the disease frequency with the different groups during the same period of time, or we can talk of the same population at different periods of time, and that is why the unit of analysis can also be time from one period to another period within the same population. Now, merits of an ecologic study, that's quick, easy, and expensive because the unit of measurement, as we said, is the whole population. You don't need individual patients to get information from. Then it can also be acceptable for developing hypothesis, for generating hypothesis. Limitation, we have what we call the ecologic fallacy, which we will explain in a little while. It does not look at individuals, and therefore it is not possible to link the exposure to the occurrence of the disease in question in the same person, meaning that's actually the ecologic fallacy. So let's give an example of an ecologic fallacy. And perhaps the most famous example of an ecologic fallacy is the Durkheim's study in 1897. Specifically, Durkheim's analyzed the differences between Protestants and Catholics. He found a lower rate of suicide among Catholics than among Protestants, and it observed that in the map of Western Europe, where Protestants are most numerous, the suicide rate is highest, and where Catholics predominate, it is much lower, and that the aptitude of Jews for suicide is still even lower, though to a lesser degree than that of the Catholics. So from that information, this particular author made a hypothesis that, or made a conclusion that suicide rates are more common among Protestants than among Catholics. Another example of an ecologic fallacy is that when researchers found that death rates from breast cancer were significantly increased in countries where fat consumption was high when compared to countries where fat consumption was low. Now, note that in both of the studies, the suicide rates, the religion, and then the breast cancer, and about fat, about obese, in both studies, the unit of measurement is an aggregate of people, not individual people and countries, and thus a valid conclusion cannot be made. And therefore, the conclusion of Durkheim's in his study that Protestants are more likely to commit suicide than Catholics is a fallacy, is not valid. And that breast cancer being significantly higher with those who have increased fat consumption is also invalid because of that ecologic fallacy. And the main reason for this is that you cannot make a valid conclusion. The main reason for that is the unit of measurement is an aggregate of people. You need to have individual people to be able to make that conclusion. But since the unit of measurement, as we said, is a group of people, then we cannot make that valid conclusion. Making that conclusion will constitute an ecologic fallacy. Okay, and this brings us to analytic studies. The analytic studies are designed to test a hypothesis of relationship. We said a while ago that when a study looks into relationship, that study becomes an analytic study. And we have two types of analytic studies: the observational study and the experimental study. When we talk of observational study, we have three: cross-sectional study, case control, and cohort study. And experimental studies, we have the randomized controlled trials, which we will discuss in a little later on, much later on. Okay, so again, analytic studies test the hypothesis of relationship between at minimum two variables, one independent, we also call it the exposure, and one dependent variable, we also call it the disease. So many times, more often than not, when we talk of a dependent variable, we are talking of the disease. And that relationship is normally depicted in a 2x2 table that's also known as a two-way table if both the independent and the dependent variables are qualitative and dichotomous. Qualitative and dichotomous. Dichotomous means there are two categories for each variable. Okay, and this is actually the two-way table, the 2x2 table, and I would like you to be familiar with this table because we'll be going back to this table time and again. So here in this particular two-way table or 2x2 table, the columns represent the disease, where D is the disease, D bar, no disease, people with no disease. And the rows represent the exposure or the independent variable, where E or the exposed is represented by an E and the unexposed represented by an E bar. Okay, A are people who are exposed and they have the disease. B are people who are exposed and they don't have the disease. C are people who are unexposed and they have the disease. And D are people who are unexposed and they don't have the disease. A and the B are people who are exposed. A and B are people who are exposed. C and D are people who are unexposed. A and C are people who have the disease. B and D are people who don't have the disease. Again, as I said, I would like you to be familiar with this table later on, and then know the meaning of this table, because we will be going back to this table time and again. Okay, when we determine the relationship between the exposure, the independent variable, and the disease, the dependent variable, we determine whether the exposure is related with the disease. Exposure is the exposure related with the disease, and in that relationship, we need to understand that the exposure must precede the disease. Before a disease happens, there must be an exposure. The exposure precedes the disease. And then we compare the number of subjects who develop the disease among the exposed and among the unexposed. So we have two groups, the exposed and the unexposed. We compare the number of people who will develop the disease or who developed the disease among the exposed and unexposed. This is how you look into that relationship between the exposure and the disease. Now, I just would like to, as I said at the beginning, that when we talk of a research design, we're actually talking here of epidemiologic research design. And really the rationale for this epidemiologic research design is to identify factors affecting the disease. In this stage of technology, we have now advanced, we're most advanced in our technology. We still do not know a lot of things about diseases. And so we need to identify factors affecting the disease. An epidemiologic study or epidemiologic research design will identify factors affecting the disease. Please remember that we are not talking of factors that actually cause, or etiologic factors that actually cause the disease. We're actually talking of factors that may affect the disease, factors that may affect the disease. For example, a very simple example, smoking and lung cancer. If we say that smoking is a risk factor to lung cancer, we're not really saying that if you smoke, you will have lung cancer. And if you don't smoke, you won't get lung cancer. What we're saying is that smoking, when we say smoking as a risk factor, when you are a smoker, you have more chances of getting lung cancer than people who don't smoke. So people who smoke have more chances of getting the disease than people who don't smoke. So smoking is a risk factor to the disease, not the etiology of the disease. Now, so let's talk first of the first analytic observational study, the cross-sectional study. And as we said, when we talked about cross-sectional study, it's a descriptive study, we talked of a cross-sectional study being synonymous to a survey or a prevalence study. Now, in a cross-sectional analytic study, we examine the relationship between the disease and the exposure as they exist in a defined population at one particular point in time. A while ago, when I talked about cross-sectional study descriptive, I highlighted I highlighted at one particular point in time, and now again, I am highlighting that. And the difference between a cross-sectional study that's descriptive and a cross-sectional study that's analytic is that in a descriptive cross-sectional study, you don't examine relationship. You just describe the population, the characteristics of that population. Whereas in a cross-sectional study that's analytic, we examine relationship. We examine relationship between an independent variable and a dependent variable. The independent is also known as the exposure variable, and the dependent is also known as the disease. And the measure of the disease in a cross-sectional study is the prevalence of the disease, Okay, so let's have this diagram in a cross-sectional study. We have here a group of people in a population. So in a cross-sectional study, we look at the population at one point in time. We look at them as either without exposure or with the disease, or without exposure and they don't have the disease, or we look at them as with exposure or with the disease, and so on and so forth. We look into the exposure and the disease at one particular point in time, at the same period of time. That's a cross-sectional study, a cross-section of the population. Just look at them. And in a cross-sectional study, because this is how we examine the population in a cross-sectional study. A cross-sectional study cannot provide to us a direct estimate of the risk. We cannot actually talk of risk in a cross-sectional study because we look at the population at one point in time. Therefore, we are unable to establish temporality to events. When we are unable to establish temporality to events, we actually call it the temporal ambiguity. And the bias in a cross-sectional study that we have is temporal ambiguity. We call that bias temporal ambiguity. And temporal ambiguity means we do not know which caused which. Is it the exposure or the disease that caused what? Is it the exposure or the disease? A while ago, when we began with the discussion of an analytic study, we told you that in the relationship between the exposure and the disease, the exposure must precede the disease. In a cross-sectional study, we do not know that the exposure, or we cannot say, I should say, that the exposure precedes the disease, precisely because we examine the population at one particular point in time. At this particular point in time, we look into this cross-section, so we cannot say that the exposure really precedes the disease. We call it temporal ambiguity. We are unable to establish temporality to events. We are unable to establish that the exposure precedes the disease. But we can still examine the relationship, though with some let us say, some conclusions, I should say, may not be valid. So with some hesitation, but we can still examine the relationship. In a cross-sectional study, when we make a study that's cross-sectional, we can generate hypotheses. So we can make another analytic study that's more powerful than a cross-sectional study. So when we examine the relationship, we compare the prevalence of the disease among the exposed and among the unexposed. Okay, I failed to explain to you what prevalence of the disease means, because we look at the population at one point in time. Those people with the disease, we call that the prevalence of the disease. Prevalence of the disease. In Tagalog, I normally translate prevalence as may sakit. People who have the disease. So people who have the disease, we call it the prevalence of the disease. Prevalence of the disease. When we look at the population, the cross-section prevalence, we talk of the prevalence of the disease. And then we compare the prevalence of the disease among the exposed versus the unexposed. So let's go back to this table, this 2x2 table. Okay, and then because I want you to understand the formula later on when we talk of the prevalence of the disease, having this in mind. So this is the prevalence of the disease among the exposed. So to be able to understand this formula, we need to look into the denominator. Look at the denominator. The A and the B, as we said, are people who are exposed. Among people who are exposed, so among the exposed, people who are exposed, among the exposed who have the disease. A are people who have the disease. So who have the disease. So this is prevalence of the disease among the exposed. And this one is prevalence of the disease among the unexposed. The C and the D are people who are unexposed, among them who have the disease. So C are people who have the disease among the exposed, among the unexposed, among the unexposed. C and the D are the unexposed. And then we compare the prevalence of the disease between the two exposure groups by getting the ratio. And what are the two exposure groups? The exposed and the unexposed. And we get the ratio between the two exposure groups, and we call that ratio the prevalence ratio. The prevalence ratio. So this is the formula, the prevalence ratio. This is the numerator. This is the prevalence of the disease among the exposed. And this is the denominator. This is the prevalence of the disease among the unexposed. Get the ratio. We call it the prevalence ratio. We call it the prevalence ratio. Okay, now listen, just go back. Later on, just for you to be able to understand the numbers that will come out later on. Okay, if the prevalence of the disease among the exposed is equal to the prevalence of the disease among the unexposed, then the prevalence ratio should be equal to 1. So the prevalence of the disease among the exposed is equal to the prevalence of the disease among the unexposed. The numerator is equal to the denominator. The prevalence ratio should be equal to 1. And what does that mean? Please understand that when we are talking of a research design, as I said a while ago, we look into factors affecting the disease. So if an exposure, A and the B, people who are exposed, looking into whether the exposure is related to the disease in a cross-sectional study, the prevalence ratio, which is equal to 1, means that the exposure is not related with the disease. So there is no relationship between the exposure and the disease if the prevalence ratio is equal to 1. Now, if the prevalence of the disease among the exposed, this is the numerator, is higher than the prevalence of the disease among the unexposed, this is the denominator, that's lower, and then the prevalence ratio should be greater than 1. The numerator is higher than the denominator, and then the prevalence ratio should be greater than 1. And what does that mean? If the prevalence ratio is greater than 1, it means that those exposed, or the exposure variable, those exposed, are a risk factor, are a risk. They are at risk of having the disease. So the exposure variable is a risk factor to the disease, except that in a prevalence ratio, as we said, we cannot, in a cross-sectional study, as we said, we cannot really talk of risks because of that bias, which we call temporal ambiguity. But we can generate hypotheses. We can say that probably that if you are exposed, that exposure variable can be a risk factor for the disease. Now, if the prevalence of the disease, that's the numerator, is lower than the prevalence of the disease among the unexposed, and then we can say that if you are exposed, you are protected from the disease. So prevalence ratio that's less than 1, if the prevalence of the disease is lower among the exposed than among the unexposed, then the prevalence ratio is less than 1. And if the prevalence ratio is less than 1, then we can say that the exposure variable is protective of the disease. So if you have the disease, you're less likely to if you are exposed, you're less likely to have the disease than if you are not exposed. So the prevalence ratio is less than 1. The exposure variable is protective of the disease. Okay, so again, if the numerator is equal to the denominator, the ratio is equal to 1, there is no relationship, and 1 is a null value. There is no relationship. Now, if the prevalence of the disease is higher among the exposed, probably by this time you should be able to understand what I'm saying. Higher among the exposed than among the unexposed, the ratio is greater than 1. The exposure variable is a risk factor, but as I said, in a cross-sectional study, we cannot really talk of risk. If the prevalence of the disease among the unexposed is higher than among the exposed, the prevalence ratio is less than 1, and the exposure variable is protective of the disease. Okay, now let's go to the next study design, a cohort study. In a cohort study, just like in a cross-sectional study, we test the hypothesis of relationship between the exposure and the disease. So you must understand that in observational studies, all observational studies, whether we are talking of a cross-sectional study, a cohort study, or a case-controlled study, which we will discuss in a little while, we look into the hypothesis. We want to test the hypothesis of relationship between the exposure and the disease. But in a cohort study, we select a study population and then subject that study population, the members, to a preliminary screening. So there is a preliminary screening in a cohort study. And those who already have the outcome, meaning those who have the disease, are excluded. So there is a screening. There is a preliminary screening. People who have the disease are excluded. They cannot be part of the cohort study. And those who qualify, who are those who qualify? These are people who don't have the outcome, because people, or you don't have the disease, because people who have the disease are disqualified. They are disqualified. They cannot qualify to the study. So only those people who don't have the disease, who don't have the outcome, are qualified. So they are grouped into two, divided into two, the exposed and the unexposed. And these two groups, the exposed and the unexposed, are followed up for a given period of time to identify people who will develop the disease. So there is a re-examination, a surveillance. Unlike a cross-sectional study, a cohort study follows up. So there is now a period of time. So there is an initial assessment where all people who have the disease are disqualified. They are not part of the study. And then only those who don't have the disease, they are now grouped into two, the exposed and the unexposed, and they are followed up for a given period of time to identify during the follow-up who will develop later on the disease. So there is a re-examination or a surveillance. In a cohort study, when we talk of cohort, we are talking of people who don't have the disease, So let's give a diagram of this cohort study. So again, this is the original population. people with the disease are excluded. So we only have people who don't have the disease, D bar, those D are excluded. So they are not qualified, and only those who don't have the disease are qualified. And these people who don't have the disease are grouped into two: the exposed and the unexposed. The exposed and the unexposed. Look at the arrow. This is, you follow them up among the exposed who will develop the disease, who will not develop the disease. So among the exposed, how many of them will develop, how many of them won't develop? And among the unexposed, you follow them up again for a period of time and then look into who will develop and who won't develop the disease. So this is a cohort study. You will note that the direction is towards the right, meaning there is a follow-up. And the measure of the disease in a cohort study is what we call the incidence of the disease, To distinguish it from a cross-sectional study where we talk of the prevalence of the disease, in a cohort study, we talk of the incidence of the disease. Please understand that incidence means development of the disease. So it means that they don't have the disease at the beginning. When you follow them up, you follow for a period of time, and a disease develops, we call it incidence of the disease. In Tagalog, I translated prevalence as may sakit. Incidence, I translated as nagkasakit, meaning at the beginning, people don't have the disease and then later on develop nagkasakit. That's incidence. When I was a medical student, it is actually in community, in family medicine, the incidence and prevalence are distinguished. And I remember my professor say many years ago, he gave the distinction of incidence from prevalence. He said that incidence, new cases, prevalence, old and new cases. When we became doctors, some of us will say incidence when we mean prevalence. Some of us will say prevalence when we mean incidence. We confuse one from the other. What is incidence? Is it new cases or old and new cases? There was some confusion, probably because it was not explained to us that the incidence means development of the disease, because it is something that the disease develops, it must be new. That's why incidence, new cases. And with prevalence, we are talking of the disease in a population, whether the disease is new or old, does not really matter, as long as people have the disease, whether they are new or old. So prevalence, people with the disease. Incidence, people who develop the disease. And in a cohort study, we compare the incidence of the disease among the exposed versus the unexposed, among the exposed versus the unexposed. And so this is the formula for the incidence of the disease among the exposed. And you will note that this formula is the same formula as the prevalence of the disease among the exposed. So the A and the B are people who are exposed. The A are people who have the disease or who develop the disease. Because this is a cohort study, we call it the incidence of the disease rather than the prevalence. And that the incidence of the disease among the unexposed, the C and the D are people who are unexposed. The C are people who develop the disease. So we call this the incidence of the disease among the unexposed. Again, this is the same as the formula for the prevalence of the disease among the unexposed, except that now we are talking of incidence, not prevalence, because this is a cohort study. And then just as in a prevalence of the disease, we compare the incidence of the disease between the two exposure groups by getting the ratio, And then we call that ratio the incidence ratio, the incidence ratio. So we have here the numerator, the incidence ratio, very much like the formula for a prevalence ratio. This is the incidence of the disease among the exposed. This is the incidence of the disease among the unexposed. And the same interpretation. If the incidence ratio is equal to 1, there is no relationship. 1 is a null value. If the incidence of the disease is higher than the incidence of the disease among the exposed, I should say, than the incidence of the disease among the unexposed, then the incidence ratio is greater than 1. And here, in a cohort study, we can talk of risk of the disease. We can talk of risk of the disease, because if you will note, and sorry I wasn't able to emphasize this a while ago, it is actually in a cohort study that we can talk of risks. We can talk of risks, because if you will note the diagram, we begin with people who don't have the disease, but they are grouped into two. Either they are exposed or unexposed, and then we follow them up for a period of time. Who among the exposed will develop the disease? Who among the unexposed will develop the disease? And in a cohort study, you can be sure that the exposure precedes the disease. The exposure precedes the disease. That's in a cohort study, and that is what we really want to have. To determine the relationship, the exposure must precede the disease, and a cohort study does just that. Okay, again, if the numerator is lower than the denominator, so less people who are exposed will develop the disease, less people than among those who are unexposed, and then we say that the exposure variable is protective of the disease. Because we can actually talk of risks in a cohort study, another name for incidence ratio is risk ratio or relative risk. And this is the acronym RR. So whether we are talking, when we talk of RR, we can talk of risk ratio or relative risk. They mean the same thing, but we can talk of risk in a cohort study. It is called risk ratio because it measures the risk of the disease among the exposed versus the unexposed. It is also called a relative risk because it measures the disease among the exposed relative to the unexposed. And in a cohort study provides the possibility of estimating attributable risk. So what is that? Attributable risk, that is the difference in the incidence of the disease between the exposed and the unexposed. So just the difference between the incidence of the disease in the exposed and in the unexposed. We call it the attributable risk. And let's give an example of an attributable risk so you will understand better. Okay, so let's first give you the formula. Attributable risk or risk difference, they are the same because we are talking really of the difference in the risk of the disease, or the incidence or risk or incidence, they mean the same thing in the exposed and in the unexposed. So note that you are just getting the difference, and we call it the attributable risk or the risk difference. And it is used to quantify, the attributable risk is used to quantify the exposed in the risk, quantify the risk in the exposed attributable to the exposure. Let's give an example. Okay, so this is a 2x2 table that talks of the exposure as medical history of hypertension. So either if you have medical history of hypertension, you are exposed. If you don't have medical history of hypertension, you are unexposed. And among people who have medical history of hypertension, and I didn't put here the total, that will be 67 plus 55. So that is 122. So out of the 122 with medical history of hypertension, 67 of them develop stroke. 67 of them develop stroke. 67 divided by 122 divided by 122, and that will be 54.9%. Meaning, among those with medical history of hypertension, 54.9% develop stroke. Now, among those who don't have medical history of hypertension, these are the unexposed. And how many of them? 39 plus 154, and that is 193. 193. Okay, so 39 of them out of the 193, 39 of them develop stroke, or that is 20.2% of them develop stroke. You will note that even among those who don't have medical history of hypertension, there are 20.2% of them who will still develop stroke. And when we talk of attributable risk, we just have to deduct the incidence of the disease in the unexposed from the exposed. So 54.9 minus 20.7. What remains is attributable to medical history of hypertension alone. You understand? So that, because as we said, not all of these people, the 54.9% who develop stroke, not all of this can be attributed to medical history of hypertension, because even if you don't have medical history of hypertension, 20.2% of them will still develop stroke. So you need to deduct 20.2 from 54.7, and the result will be the attributable risk, meaning, and this is the result, the 34.7 or 0.347 or 34.7% is the risk attributable to medical history of hypertension alone. So that is the meaning of attributable risk. We need to deduct this number because even those without medical history of hypertension, they can develop stroke as well. So what is attributable to medical history of hypertension alone is the difference, 34.7. Okay, so, okay. I don't want to discuss now the case control study because I would like to end here because I might not finish, and then so we'll just finish the cross-sectional study next time. So so that's all. So thank you for listening. So hope you'll be able to review this and be able to understand at least the observational study up to the cohort study. Again, thank you.